All right, gentlemen, this is our probability test study guide for Thursday, October 5th, or 6th, excuse me. Let's go ahead and get started. So, an event is a collection of possible outcomes. An action or trial that has varying results is an experiment. The sample space is a set of all possible outcomes. For example, a sample space of flipping a coin is heads and tails. Rolling a six-sided dice, 1, 2, 3, 4, 5, 6. So, like, those are some examples of sample spaces. Theoretical probability is the number of desired over the number of total. We talked about this a while ago. The probability is the chance that an event will occur, and the probability of two events at the same time happening is calculated by multiplying the probability of the two independent events. And conditional probability is the probability of event happen given. And this is something that's very, 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 very important. If you ever see given inside of a question, you know that you're going to use this formula. I don't think I write it anywhere else. So this is probability of A given B, and this is equal to the probability of A and B over the probability of just B happening. So this is A given B. This is A and B. And this is just probability of B. So that's very important to note. So let's go and start. So I have a six-sided die with numbers 1 through 6 on it. So let's just write out our sample space. We have 1, 2, 3, 4, 5, and 6. So we have 6 total outcomes. So now we want the probability that we roll a 4. So our desired outcome is we get a 4, and there's one desired outcome over 6 total. Now the probability that we get an odd number, that's going to be a 1, a 3, or a 5. So there's 3 desired outcomes over 6 total outcomes. The probability we get 9. So what's the probability we get 9? Is 9 even in our sample space? No. So it's 0 over 6, or just 0% chance, because 9 is not in our sample space, or all the possible outcomes is not even in it. So now what we're going to do is flip a coin and roll a six-sided die. So let's actually set up what this might look like. So we have our original, and we can make this tree of heads and tails for flipping a coin. And then all of our possibilities after that. So there's a few different ways we can do it. We could do it looking at a tree, or we could just do it based on probabilities. So what is the probability that I flip heads and roll a number less than 3? So the only time we need a heads, and we need less than 3. So that's only a 1 or a 2. So our desired outcomes from this bottom row, there's 2 of them, and our total outcomes is 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 over 12, or 1 over 6. The other way we could do this is just think about the probability of each one of these individually. So probability that I flip heads on a coin is 1/2. And the probability that I roll a number less than 3, so once again, that's only rolling a 2 or a 1. There's 2 desired outcomes out of 6 total. So we get 2 over 12 again, and that's also equal to 1/6. Remember, when we're multiplying, you multiply straight across. So 1 times 2 is equal to 2. So like 1 times 2 is equal to 2. 2 times 6 is equal to 12. So that's where we get the 2 and the 12 from. Easy enough. Next, what's the probability I flip tails and roll a 5? So let's choose a different color. Let's choose green. So tails and a 5. Now we only have one desirable outcome out of 12 total. And we could do the same thing we did before. Tails is 1/2 times 1 over 5, over 6 total outcomes. So it's 1 over 12. So there's two different ways to get these answers. Choose whichever one you're more comfortable with. All good with me, doesn't matter. Let's talk about some M&Ms. So bag has 4 red M&Ms, 3 blue, 1 yellow. I say I just drawing a picture if you're struggling. So let's just go ahead and start. So what's the probability that I get a red M&M, put it back, and get a yellow one? So probability to get a red one is 4, because we have 4 red M&Ms and we have 8 total M&Ms, because 4 plus 3 plus 1 is equal to 8. So 4 out of 8 for red M&Ms, and then I put it back, so I'm not eating it. My total M&Ms stays the same because I put it back. And then I want to know what's the probability I get a yellow one. So we're going to multiply. I only have one desired outcome here with the 8 out of 8, I should say. So one desired outcome. So I have 4/8 times 1/8. So we're going to get 4 over 64 or 1 over 16. Now what's the probability I pull blue one and I eat it? So pull blue, that's going to be a 3 out of 8. If I eat it, what happens? I don't put it back. My total then goes down. So once I eat it, the total goes down. And then so what I want to do is, so this is the first one, and then I want to pull another blue one. So now I took a blue one out of the bag and I ate it. So how many blue ones are left? There's only going to be 2. So I'm going to have 2 blues, and that's out of 7. So let's actually just draw a picture real quick. So let's go red, 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 red. We got a blue, 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 and we got our yellow. So we could very easily see that if I have this full bag and I pull one blue one, I have a 3, 1, 2, 3 out of 8 total chances to get it. And let's say I take this one and I eat it. So this is eaten down here. I now only have 1, 2 desired outcomes where we get the 2 from, and 1, 2, 3, 4, 5, 6, 7 total M&Ms in my bag. So that's where the 2 7s comes from. So we're gonna get 6 over 56, and this it does simplify, but because we didn't talk about how decimals work with percentages, I'm going to go ahead and let it slide for this. So, probability I pull a red one and I eat it. So we could actually just put our blue one up here. Probability I pull a red one in general is 4 out of 8, because we got 4 reds. I'm eating it, so let's take one of our reds away, not the blue. And then pull a yellow one. So now I have 1 yellow, so that's my desired, and I have 7 total M&Ms left, so it's 4 over 56. So now what I want to do is find, or probably I pull a blue one, given that I already pulled a red one. So if I've already pulled a red one and ate it, this is like taking this one out of it and putting it down here. But let's go ahead and do it in the given fashion. So probability that I pulled a blue, pulled blue, given that I ate a red one. So given that I ate a red one. So we might have to think about this in a little bit more of an interesting way. So blue and eating a red over probability of pulling a red and eating it. So the probability that both I pull blue and I get a red one is just the probability of the red one times the blue one. So think about it like that. So the probability to pull a red one is 4 out of 8. If I eat it, our total goes down. Again, so I take this, throw it out of there. So now I'm going to have 3 over 7. And probability of eating a red one, that's 4 over 8 again. These two cancel out, so it's just 3 out of 7. This question is slightly more straightforward, and you might be able to figure out this 3 out of 7 without doing this. I recommend doing this every time. It's just going to help you get in the habit, get in good habits for dealing with the next few questions that are definitely going to appear in some way, shape, or form on the test. Just write this out every time. It's going to help you in the long run. So now the probability that I wear an OSU quarter zip is 3 out of 10. The probability that I wear the quarter zip and watch football is 4 out of 15. So what's the probability that he watches football given, there's our magic word, that he's wearing the quarter zip. So I want the probability that he watches football, so football given quarter zip. So this is going to be equal to the probability of football and quarter zip over the probability of the quarter zip. So I tell you the probability that Michelle was quarter zip is 3 over 10. So 3 over 10 is going to be on the bottom. Probability that he wears the OSU quarter zip and watches football. So that's exactly what this says. Football and quarter zip. It's 4 over 15. We can solve this by multiplying by the reciprocal. So 10 over 3. So it's 40 over 45, and this then goes down to 8 over 9. So now we got this question where Ronaldo shoots one-on-one with the keeper. He has a 7/10 chance to score a goal. Now the probability when he is one-on-one with the keeper and he scores with his left foot is 4 out of 15. So Ronaldo shoots. What's the probability he scores with the left foot given? There's our magic word again. Given he is one-on-one. So we want the probability that he scores with his left foot given he's one-on-one with the keeper. So that's the probability of the left, let's make this a little more clear, left and the keeper over probability of being one-on-one with the keeper and scoring. So when he shoots one-on-one with the keeper, he's got 7/10. So that's this probability. And when he is one-on-one and he scores with his left foot, that's 4 out of 15. So now it's the same deal. We'll have 4 over 15 times 10 over 7. So that's 40 over, 105. So 21 over 8. Yeah, that sounds right. 21 over 8. Yeah. So that's that. So there's a 25% chance it'll be cloudy, a 3/20% chance it'll rain and be cloudy. So what's the chance it rains given it's cloudy? So we want probability that it rains given it's cloudy. So that's going to be the probability that it rains and is cloudy over probability that it's cloudy. Excuse me. And so we just fill in stuff. So 25% said it's cloudy. So we could write that as 1 over 4. And 3/20 chance it will rain and be cloudy. For the and, to help you fill in this top part, once again. So 3 over 20 is going to equal 3 over 20 times 4 over 1. Or 12 over 20 and divide each by 4, 3 over 5. The probability that Myles Garrett is hurt is 15%. That's tragic. Probability that the Browns win the game and Myles is hurt is 2%. What's the probability that Browns win a game given that Myles is hurt? So this is going to be probability that there's a win given Myles Garrett is hurt, which is probability of a win and he's hurt, over the probability that he's hurt. So this is going to look like 0.15 over 0.0. Oops, I got this backwards. My fault. Wait, no, I didn't. We're good. So 0.2 over 0.15. So that's how you're going to do percents. You can hit up my handy dandy calculator. I believe this is like 13%. Yeah. Oops. 0.2 divided by point. Oh, I see what I did. Oops. 0.02. 0.02 divided by 0.15. That is about 13.3%. So now we start to get a little tricky. If 30% of students are good students and 20% are good at basketball and only 5% are good at both, we want the probability that he's a good basketball player is also a good student. Now I need a given in somewhere. I remember I messed this up. So there's supposed to be a given in here. So I apologize for that. So it's our probability of basketball given good student. So it's the probability of basketball and a good student, good at basketball and good student, of the probability of a good student. So probability of basketball and student is this 5%, so 0.05 over probability of good students is oh my goodness, sorry, 0.3. So this is going to be 0.05 divided by 0.3, and that's 16.67% repeating. Well, it's actually 0.66 repeating. And that's the answer. So now Mr. Shell carries the ball up 4 out of 5 times in a basketball game. The probability that he brings up the ball and scores on a possession is 1 out of 10. So what you're saying is Mr. Shell's trash at basketball, which is fairly true. What's probability scores given he brings up the ball? So we want. Oh, what happened to my pen? Is it dead? I really hope not. That would be tragic. Okay, so probability he scores given brings up the ball is equal to the probability he scores and brings up the ball. Probability he brings up the ball. So fairly easy. Michelle carries the ball 4 out of 5 times. So that's probability he brings up the ball. And this is the probability he brings up the ball and scores. So 1 over 10. So 1 over 10 times 5 over 4. 5 over 40. And that's 1/8. So that's not good. Not good. Need to work on my shot. Anyway, whatever. Let's keep going. So now we're going to talk about using a table. So use the following table to answer some questions. Table is a survey of students and what their superpower of choice would be. So this table, unlike some of the other ones you've seen, I already have the totals for you. So our total people in this experiment is 100. We have 48 males, 52 females, and then people want to be able to fly or be invisible or do something else. So let's go ahead and look at the probability we want to fly. So the total people flying is 38 because that's male plus female. So our desired is going to be 38, and our total is 100. So it's just 38 over 100. And like I said, we don't have to simplify for now because I messed it up. So our total number of males, you look at the male column, you could add everything up, or it just gives you the total. So 48 over our total is 100. So now I want the probability of male given they would like to fly. So this is going to equal to is probability of male and fly over your probability of wanting to fly. So your probability of male and fly is 26. That's the intersection of male and fly. So it's 26 out of your total of 100 over probability they want to fly is 38 over 100. So 38 over 100. Do some cross multiplying by the reciprocal. There we go. And you'll get 26 times 100 over 38, or 26 out of 38. Probability that you want any other superpower given that you're female. So this is going to look like probability of other and female given that we are a female. So if you want something else and you're female, you're going to have 8 out of 100 over probability that you're female. So our total number of females is 52. Total number of people is 100. So we just get 52 over 100. Do some more cross multiplying, or excuse me, I said it again. Some more multiplying by the reciprocal. And we get 8 over 52. Like I said, we could just not simplify for now. Now, probability that invisibility, or that you want visibility given your male, so that's probability of I given M over probability of M. I know our probability of being a male is 48 over 100. And the probability of invisibility and male is the intersection of male and invisibility. So it's 12 over 100. Oh, this is a nice one. So you're going to get 12 over 100. When we're multiplying by the reciprocal, finally said it right. 48. That crosses out 12 over 48. And that becomes 1/4. So I'll leave this on the screen because I went through that really fast. But this is the conclusion of the video. Like I said, some of these questions are going to be fairly similar, if not exactly the same. So keep an eye out for that one. I might post some more resources as well as some other videos that might be helpful to watch on Google Classroom. So also keep an eye out for that. If you guys got any questions, I will be available all day Wednesday after school. I will also be available Thursday morning, and my free periods are 1, 5, and 9, and I have a study hall in my room 7th period that you can also come into. Just get a pass from your teacher, and you're good to go. Okay?